On today's episode of The Code Files, Most Efficient Criminals, we're diving into the first ever computer science RICO case. The suspect, a mastermind, accused of engineering the most efficient trap network the city has ever seen. No wasted gas, no backtracking, no drama, a perfect system. Sources say he didn't just trap, he optimized. And this is what one of his goons had to say about him.
They say, man, the hood culture was one of them ones. He always used to say, I'm your favorite rapper's favorite rapper. I'm your favorite trapper's favorite trapper. And he always used to say he hit the rest of the yams at his auntie's house. I don't know what that means. I never understood.
The confidential informant decided he wanted to remain anonymous because he had the fear of being Swiss cheesed. We're not sure what that means right now, but we'll get back to you on it. And on today's episode, we have the hood coder himself to explain how he built his trap empire using Prim's algorithm. Say, I need you to look and lock in because I'm going to make Prim's algorithm real simple. Now it's time for the process. And for the first part of the process, we have to pick a starting point. So a starting vertex. And we can pick anyone we want. Then we have to find the cheapest edge that connects to a vertex that we haven't visited yet. But here's the trick though. Even after you move forward, you can use old vertices to find a new path. In order to keep this organized, we use something called a priority queue. And this gives us the cheapest edge available. And we keep doing this until we visit all the vertexes, and this gives us our minimum spanning tree. Now we're finna do an example real quick. For this example, let's start with vertex A. Now look at all the edges that are coming from A. We have A to B, A to E, and A to F. And the cheapest option here is gonna be from A to B, which is 3. So we pick vertex B and we add it to our tree. Now it's time for step 2. Now since we visited B, we got a couple more options here. We can go from B to C, we can go from A to F, or we can go from A to E. And the cheapest option here is going to be from B to C because it costs 1. So we added C to our MST. Now it's time for step 3. And for step 3, we're looking at all the edges coming from A, from B, and from C. So our options are from A to F, A to E, B to F, and C to D. And we're going to go ahead and we're going to go with from B to F because that's the cheapest option here. Now we have A, B, C, and F in our MST. In this step, you might have noticed that B to F and C to F had the same cost. So why did we go with B to F? We went with B to F because it entered the priority queue first. Now look at step 4. We have to look at the edges coming from A, from B, from C, and from F. And our options are from F to D or from F to E. And we're going to go with from F to E because it's the cheapest option, which costs 2. So now we got A, B, C, F, and E in our MST. Now we're on the last step, which is 5. And we know it's the last step because there's only one vertex we haven't visited, which is D. So the cheapest option here is going to be from F to D, which costs us 5. Now we hit every vertex. Hey, in the comments, let me know if y'all want the code for Prim's algorithm. Now we completed our MST, so now you can see how I built my trap empire. But now I need y'all to drop a like on this video so I can beat this RICO case.